In this video, we will focus on bootstrapping and its applications in supply chain management. Bootstrapping is a statistical technique that falls under the broader heading of resampling. It is a type of resampling where large numbers of smaller samples of the same size are repeatedly drawn with replacement from a single original sample. When going to your local car dealer, the car salesman offers you an umbrella of different car features you have to choose from. It goes from colors, types of seats, engines, to the navigation systems you want installed in your car. The car is then built to your exact specification, and this is what is known as a factory order. Lead times for factory orders vary from product to product and could be anywhere from, let's say, 2 weeks to up to even 6 months. The lead time corresponds to the time between the initiation and the completion of a production process. The supply chain of a car manufacturer consists of several vendors with unique operating characteristics and variation in their lead time. With each addition of vendors in a supply chain, additional factors contributing in lead time, variations and opportunities for delay in delivery increase. It is important for vendors to promise a lead time that they are confident they can meet. In order to find this lead time, the bootstrapping method can be used to estimate confidence intervals and provide an accurate model of what can be expected based on the number of tiers in a supply chain. In this video, we will take the car manufacturer Audi as an example and use the bootstrapping method in order to estimate the confidence interval in which 90% of Audi's expected lead times are likely to be fulfilled. Let's pretend that we are the car manufacturer Audi. We have a list of empirically collected lead times we have previously faced, and we now want to estimate future lead times for our customers we can actually meet. This with a confidence interval of 90%. Therefore, we choose to use the bootstrapping method. In the first step, we take a look at a sample of 10 different lead times from previously gained data and then sort these in ascending order. We also added a graph to illustrate the variations of these lead times. In a second step, we simulate 20 different bootstrap samples. In order to do so, we use the index formula. Excel therefore considers all 10 values from our original sample and randomly picks one out of these 10 given values. We then copy the corresponding formula down to all the other cells and generate a randomized selection for our first bootstrap sample, which is based on our original empirical data. Now we need to calculate the average of our first bootstrap sample. We then apply the formula to all of our 20 samples and again calculate all corresponding averages. One should note that each time we change a cell on our Excel sheet, new random numbers will be drawn. We are now faced with 20 bootstrap samples, each with their corresponding averages, and we will now build upon this data. In the next step, we have to sort the previously calculated mean values from the smallest to the highest value, using the small formula. Now we want to find the interval in which 90% of Audi's expected lead times are likely to occur. In our example, we can use a high confidence interval because of the fact that a lot of data is available when it comes to the car industry. Also, our data is drawn from an unknown distribution. Therefore, the confidence interval cannot be calculated by simply using a t-test, for example, because data is not normally distributed. That is one major advantage of bootstrapping. It can be applied even if distribution is very complex or unknown. In the beginning, we calculated the mean of our original sample, which represents the true mean for our delta formula. To calculate the confidence interval, we now have to find out how much the distribution of our computed x bar values from our bootstrap samples vary around the true mean of our original sample. Delta is therefore reflected in this formula. After finding the distribution of delta, we will then find the 0.95 and the 0.05 critical values of delta, which define the limits of the 90% confidence interval. Looking at this formula, one can see that the probability that x bar varies around the mean in between the critical values of delta 0.95 and delta 0.05 is 90%, which in turn gives us this formula for the 90% confidence interval. So how do we apply this to our case? So far, we have computed the x bars for each bootstrap sample and sorted them. We now need to select 90% of these collected averages. In our case, this corresponds to 18 values. We therefore highlight the necessary 18 values. Now we have to calculate delta for every single bootstrap sample, which corresponds to the adjusted value. For example, to get delta for our lowest bootstrap sample, we have to subtract the mean of our original sample. Again, we apply this to all 20 samples of our bootstrap. Furthermore, you should not forget to fix the average value of the original sample. We are especially interested in the upper and lower boundaries, so we highlight them in red. These represent the critical values for our confidence interval. In the last step, we now have to use this formula to calculate the limits of the interval. First, we subtract the 95th percentile from the mean of the original sample to get the lower limit. Secondly, in order to obtain the upper limit, we subtract the 5th percentile from, again, the mean of the original sample. We eventually get the confidence interval we wanted to calculate. We find that 90% of the expected lead times will be between 82.1 and 115.1. In this example, only a moderate amount of bootstrap samples has been chosen. However, in order to obtain a very precise estimation, one will need to generate much more samples. One should note that the bootstrap method can have limitations, and one of them is that bootstrapping does not overcome the weakness of a small sample as a basis for inference. Additionally, the accuracy of the collected data representing the characteristics of the population is of great importance. Conclusively, this video aimed to illustrate the bootstrap method, in particular the detailed calculation of the confidence intervals and the application thereof for lead times in the automotive industry.